Okay, I think we'll get started in just a minute. Just to make sure, we're here for TLS. Alrighty, let's get started. You all are probably familiar with Note Well, which is respect to IPR and the IETF. So please take a quick look at this if you're not familiar. You can also find it on pretty much every thing that you get from the IETF when you're signing up. Next thing we'd like to mention here is the IETF Code of Conduct. So this is something we'd like to emphasize, that we always want to treat our colleagues with respect. Try to make sure you speak so people can understand. Using reasoned arguments is better than trying to attack somebody's person. Using your best engineering judgment to find solutions for the internet as a whole. And we all want to keep that in mind, and that people often have different points of view on coming from different experiences and backgrounds. So keep these in mind when coming to the mic, speaking on Jabber or on the mailing list. Thanks. All right, do we have minute takers? I didn't notice if we had, I don't think we had requested it. Is there somebody who's willing to take minutes?
Yeah, this is Rich. Yeah, Rich, I'll do it in the hedge doc thing.
Perfect, thank you. And I think probably we'll have a number of people in Jabber, but if somebody wants to speak and doesn't have audio access, we can relay that to the mic. And again, state your name when you're speaking, and then keep it professional. All right. So we have an agenda. We'll have a couple discussion, a couple working group drafts. Looks like we've had a revision here already. And then we'll have a discussion of some new work that people have brought to the TLS working group. Is there any agenda bashing that we'd like to do at this point? Any additions? Alrighty. I think the next thing is just a quick check on document status. We have a number of things coming up into the RFC editor queue. There are some drafts that have been in this state, in their various states for some significant amounts of time, usually waiting on author action in auth 48 or waiting for some revisions. The document shepherds will be following up with you to strong arm you into getting some of these things to move forward. Some of them may be relying on the chairs too, but these are things that we want to try to push forward. Other than that, I think we have a number of things in flight, so it's good work by the working group. Good to see that we're making progress in a lot of areas. So without further ado, I think we will start on our first topic, which is exported authenticators. Who's presenting that?
That's going to be me.
Do you want me to run the slides?
Yeah, could you run the slides? There's only two of them, so, or three technically.
Okay. Let me just find them, sorry. There we go.
Hi, so this is Nick's draft, but I think he's out on vacation. But basically, I'm here as the document shepherd to try to get this document to the finish line because it's been through ISG review and we have one lone comment remaining from Ben Kadek, and I want to make sure that we get it reviewed. Next slide. So again, we got one comment from Ben, and could basically be summarized that he noted are there any security issues caused by the fact that the exported authenticators is based on the exporter secret, which does not incorporate the entire transcript. And this issue kind of arose during the TLS 1.3 discussions that were on the mailing list. And Nick basically said, hey, it'd be great if Jonathan could look at this. Jonathan did take a look. He did an analysis and proposed 2 ways forward. There's links there to the emails and the proposal. The response basically was like, hey, we could add security considerations to address this, or we can change how the exporter works. And what he proposed was the security consideration, and that's what we're going to review next. And so we've basically taken the approach that since no one has suggested the other option, that we're going to go with this. So he proposed some text. I guess Rich commented on it, and so we're curious to see that. Is this done? Does anybody want to add anything? Is there anything new that we need to add, or can we just call this closed? Going once. Going twice. I did note that Martin Thompson suggested in the draft that the short answer is that this is fine, and that TLS 1.4 or whatever the next version will be numbered might want to include the entire transcript under the exporter secret. Watson also suggested that it was ready to go. So with that, I think we're going to go ahead and get this merged and get this draft done and get it in the RFC editors queue. So thank you for your time.
Becker, were you waiting to speak on this issue?
Yeah, I'm sorry. I'm having trouble understanding what it says. So, I'm trying to understand what this says because, like, what, how does the service and application data do anything useful here? The client's final flight is not included in the traffic keys.
So if I can jump in, Ben Kadek, I think that the application data is going to trigger the server to reject the connection or close the connection if it doesn't like the client certificate.
But no, but the EA doesn't involve the client. I don't understand this. The certificate request is sent in the channel after the handshake is completed, right?
The EA certificate request?
Yeah.
Can I jump in?
Please.
The EA request can be done out of band, so it is not necessarily sent after the connection is complete. It can be sent, for example, by the server as long as it's computed the server finished. So if the client then sends back a malformed finished message or something, then you're not guaranteed, like the server at the time it computes the request doesn't know that the client will successfully complete the handshake.
Okay, but how does sending application data help?
So the only thing that includes the client finished is the resumption master secret. So producing a message that uses the resumption master secret first, before you make this request, guarantees that the client and server already agree on the client finished.
Okay, but how does sending application data do that?
Because it's a implicit versus explicit authentication thing. Once you send your first thing of application data, the server has to agree. If the server's received it, it has to agree on the client finished, or it will abort the connection.
I don't understand. This is the server sends an application data, but we're sending it to the client, and the server sends application data as soon as it receives the client's first flight. So the server gets application data without ever even seeing the client's second flight. I just understand what this text does. I understand the problem we're discussing, but I understand what this text does.
Right, and I think there is a difference between new session ticket and application data and reading and writing application data. Thanks, DKG, in the chat.
But also the NST, the NST also doesn't like guarantee agreement on the resumption master secret because you have to resume to get that information.
If I have for the server to compute the resumption master secret, to produce an NST, for the server to manufacture an NST, it must have received the client finished.
No, not if you're not doing client authentication. The servers are supposed to be permitted in fact not to do that.
Resumption master, I'm looking at the key schedule now. Resumption master.
Yeah, but you can predict the client's final flight if the client is not authenticating.
Correct. Like I don't understand. Like the server. Like why aren't we just telling the server don't do this? Like don't do anything. I mean, like I just understand. Like if we want the server not to do anything before receiving the client's finished, don't do that. Like I'm sorry. Like this just isn't clear enough for me to agree it's just like ready to move forward. So like I think like I guess I mean we have to go read the issue. I have to go read the issue, but like I don't think this text I don't think I guess what I would say is I don't think this text is clear enough to put in the specification. Like it doesn't properly explain the issue in a way that one can understand it, and that's the condition. So I'm happy to go read that issue and try to understand what it's actually saying. But whether this text is in there or not, I don't think it's clear enough to put in the specification.
Okay, so we'll go back and clarify the text.
I'd be a place to start. I mean, I guess I'll try to read the issue and see if I understand it.
I tagged you as a review hacker.
Thanks.
That'll work. All right. Thanks, Joe.
Flags are next. You out? Are you here?
Yes, I am.
All right. Can you request to share slides?
You want share? I can share if you want.
Yeah, that
just
should probably work better.
You up? Can you request to share?
Oh, I thought you were doing that.
I can.
Where is that?
Right next to the join queue button, there's a request to share preloaded slides button.
Yeah.
Perfect.
Okay. So, hi. Talking about the TLS flags draft. And so what's happened since the last IETF? Oh, that's a bad font for 111. So we've gone through working group last call. We added the requirement to drop malformed packets and published version 07 that includes this requirement. So are we done? Not necessarily. There's three issues that maybe are open. So the first one is about the guidance for IANA experts. So section 4.1 contains guidance on how to assign numbers to the flags. And it's kind of a complicated thing. So 0 to 7 is for things that are like everybody has to implement them. I was thinking of RI or a new thing like RI. And then we have number 8231 that's for things coming out of this working group or specific requested to have a small number. And then from there on, it's things that are maybe standards tracks, but not but are more specialized. And then there's experimental. It's kind of a complicated thing. So Martin Thompson opened issue number 11 and suggested to remove all advice and leave it just to the discretion of the expert. And I think that giving the expert some rationale is important, given if it's at some point in the future when I'm no longer the expert. So far, I haven't made any changes to the draft. If the working group wants to make the change, then we can do it. Yes, Martin.
I don't think I made that specific suggestion. What I was concerned with was the very specific set of rules, you had specific boundaries that you'd set. So you had, now I'm just running off memory. I'm going to have to go and look at the draft again, but there were specific points that you had that you said have to follow a particular rule. Flags 0 to 7 have to be out of the working group, and 8 to 31 have to be standards track documents with very specific conditions on that, and 32 to 63 are experimental and that sort of thing. And I think that what you want to provide is general guidance to experts, and maybe reserve the top few flags because they're super important or something. But the level of specificity here is far in excess of what I think is reasonable.
Mm-hmm. You can see that practically the IANA people always ask about every assignment. They don't just say, oh, well, we figure out through the rules and we think that you should do that one. No, they always ask. So, yes, Eric.
I basically agree with Martin's guidance, which is like, if we think that so obviously, like just so we're all on the same page, to restate the obvious, the resources being conserved is a big pile of zeros at the front of the flags word, and so I agree with MT. Like, and first of all, I guess like this is already a relatively small amount of data, so I'm not too bad shape that as long as you don't start like reserving out like way the heck out. But so I think like my sense would be like, let's reserve like 0 to 7 or 0 to 15, like if you feel that's appropriate for like working group discretion, everything else should be allocated in sequence right after that. And if this turns out to be like a nightmare and we have like a hugely sparse thing, then we can invent like a new flags thing with like row length encoding for zeros or something. But like I just like trying to spend a lot of effort trying to like optimize down that last layer or two. I mean, that's the kind of thing CTLS tries to do, but I don't think it's particularly helpful in TLS. I mean, the handshake's already quite large.
So I'd be happy with suggested text to replace what there is right now in 4.1.
And MT, do you want to take that, or you want me to take it? I think you had some strong. You probably thought it was more than I have, because like I thought about it for like a minute or two.
Yeah, I can.
Okay, great.
You should be, and I'll. No,
Okay, so can we go on to the next issue? Okay, so the next issue is about the recommended flag in the IANA registry. So the recommended flag is in the new registry, the registry for flags is what it says right now is recommended, which is either Y or not, or Y or N, value determined in the document defining the optional feature, and doesn't say really anything about when we should be when it should be recommended, when the flag should be recommended, and when it should not. The assumption was that it's the same thing as in all the other registries and specified in RFC 8447. So do we need an extra line of text that says so explicitly? The meaning is like in RFC 8447? Yes, Joe?
Hi, this is Hannes. Yeah, I thought it would be good to have some extra text, as I mentioned on the mailing list. Like, this is everything but clear. Like, just have something meaningful there. What recommended here actually means. Like, I don't
So-
care what it really is, but not saying anything, I think, is not a good idea.
So it's saying this is the same as what it says in section 5 of RFC 8447, which defines the recommended column for all the other registries?
Well, in this case, it's a little bit different because, like, you are defining flags which by its own nature are very different from in the general purpose extensions. Like, the flags refer to the need for having something optimized, right? That's why the flags are defined, right?
Semantically, they're just like an empty extension.
Well, I went through the list of extensions, and even with with the language from the TLS RFC, like, many of them don't make any sense. Like, recommended for what?
So that's what section 5 of 8447 is for. It means that, oh yeah.
Yeah, I can propose some text as DKG proposes, but I'm in general against, like, just putting some columns there and populating with values. Nobody knows what they mean, like, and these type of things.
Mm-hmm.
So I guess oh, sorry.
I guess at least they mean that we expect all or most implementations to implement this flag because it's recommended. That's the informal way of expressing it.
Yeah, and I think maybe this is something we would touch on with RFC 8447 BIS discussion later on, but I think some of this may be around ambiguity about what recommended means in general, or the yes and no. I think there's things that need to be clarified there, and I would hesitate to put something too specific in here when that should really be clarified in 8447.
So that tells that it's a good idea to just refer to 8447 or maybe quote a line from there. And wait for an update to come and update every registry, including this one. Yes, John?
Yeah, if it's updated in 8447, that's enough. But I think we should not introduce more of this confusing one bit recommended, which I think and people outside of the TLS working group does not understand what that recommended means. But fixing it in general would be even better. Yeah.
Mm-hmm. Okay, I'm still not getting guidance on what to do with the draft.
I think this column should look exactly like the column for other extensions. And so we should defer this discussion to 8447. And when we discuss 8447, this, like, whatever the heck we decide, like the ought to be what's applied here, because these are, as you say, they're just like regular extensions. The purpose of this field is not to say space, is to indicate to people what things IETF has confidence in and what things it does not have confidence in. And it's certainly possible to have a 1-bit extension which you have no confidence in. Have a 1-bit extension that says, like, don't encrypt anything. Like, we have, like, very low confidence in that. We have very high confidence it was bad. So, like, I certainly think it's possible to have 1-bit extensions which, like, have an opinion on positive or not. So So I don't think that, like, the encoding really is relevant to this question of what the meaning of the columns is. So, like, my vote is that this column, this merely is exactly the same as the other one, and then we can debate in like about 20 minutes what the other one means.
Okay, sounds good.
Hey, John, I wasn't sure. Are you still in the queue? Hey, I think the easiest thing to do is to just reference 8447. because then you don't have to worry about updating it, this document, if you end up deciding to change the other values, because then that document has to update two things. So it's probably best just to point and then move on and just kind of deal with it. This thing will go in the RFC editor's queue and it can wait for the BIS document, which hopefully shouldn't take all that long to catch up.
Okay. Right. So I'll go to the last issue, probably the more controversial one. So about DTLS 1.2. So Akim Kraus, sorry if I'm butchering your name, opened issue number 13, asking for the flags extension to be defined in DTLS 1.2 as well. It's already relevant for TLS 1.3 and DTLS 1.3. They want it for DTLS 1.2 as well. This will be useful for DTLS RRC, return routability check, which does address DTLS 1.2 as well as DTLS 1.3. So currently the TLS flags is only for the 1.3 versions. So up to the working group if we want this to also somehow apply to DTLS 1.2.
The backstory here is for the working group is that typically when we start working on new extensions, the default is that they apply to 1.3 and later, and not backwards, and that we have to kind of make an explicit decision to go back and try to support something that essentially backported to 1.2.
Yeah, so one thing is that if we do this if we add this to DTLS 1.2, then we have to have another column that says, does this apply to DTLS 1.2 or to everything? Or rather, is this flag only 1.3 or only 1.2 or both? Yeah. Ben?
I think you sort of started to touch on the point I got in queue to make, which is sort of the scope at which the protocol version applicability is applied over. And so, right now we're saying the TLS flags extension is 1.3 only, and sort of there is the conclusion, the corollary is that all of the individual flags are also 1.3 only. So if we start saying that, okay, the flags extension itself can now be used in 1.2, like, is the scope of that literally just the flags extension, and then we have to say something else about each individual flag? Or is the implication that all of the flags contained within it are also applicable to TLS and DTLS 1.2 as well? Because if that's the case, then there's a really severe implementation burden, as David Benjamin noted, where now if you're a dual stack and you want to implement a new flag, you have to implement it for both protocol versions at the same time. And having recently gone through this exercise for raw public key, it's kind of tedious to have to do both protocol versions. It can be a fair bit simpler to only work on the TLS 1.3 version. And I also don't think that there's a very strong argument for adding the extra granularity and having each individual flag say, is this valid for TLS 1.2 or not? But I also don't have a great argument against it.
Yeah, Hannes?
Yeah, this for me, this is really a very practical issue. Like I was working on the update of our implementation for the CID, and also this return routability check is part of that story, and we have the 1.2 and the 1.3, and the question for me was like, I have to provide features for both because both provide this CID for DTLS. What should I do? Do I have to write a different extension for 1.2 and again use the flags extension in 1.3, or what's the story? And that's why I was asking for that on the mailing list. And in general, of course, it raises the question of like, what happens with the DTLS or with TLS and DTLS 1.2 in general? Like if someone wants to sort of define an extension, and probably this is less, fewer people want to do that, but it will be out in the field for a while because it's still a fine protocol like this. It's not broken if you use it with the right algorithms and the right settings.
Well, and and we have already decided that RRC does apply to DTLS 1.2. It's not just
Yeah.
the latest version.
Mm.
Mhm. But I guess we could work around the complexity of having the same extension by making this two extensions, one flags for 1.2 and one flags for 1.3. And if you want a certain flag to apply to both, then you just update both registries, add a flag to each extension. It's a bit more complex, but the complexity then dies with 1.2. Yes, Ecker.
I guess I tend to think this is a set of pragmatic questions, because no answer seems ideal. You know, basically, it is as a hassle to have like Ben support like this for 1.2 and 1.3. I think if we were going to do that, we would have to say whether it's 2 code points or 1, that these flags are valid for 1.2 and not valid for 1.3, and vice versa, right? And probably we shouldn't define any that are valid for 1.2 only. You know, like it's not. I think like I guess the question I would have is like, you know, like is like the people who would like to have this for 1.2, like how inconvenient is it to like not have it? If the answer is like really inconvenient, then we should do it. And at the end, and if unless the end, because I already heard from David Ben and Benjamin Kadek, that's like not that inconvenient to like implement. It's just kind of inconvenient, and so I don't feel that strongly about it. So I guess like, you know, I'd like to hear from Hannes and other people who sort of like think this is valuable. Like this is getting a real pain in your ass if we don't do it. If the answer is yes, then we should like do it. Even though like kind of is annoying. And I guess I would observe like, you know, you could just not do it the whole time.
I mean, it's all
Ecker, to your point, that's where I was going to go, is that, you know, apparently this could be useful. Well, like useful, like how useful? Like you're going to use it every time you send a DTLS 1.2, you know, set up a DTLS 1.2 and handshake, or not. So that's kind of where I'm kind of thinking about this.
I don't know. I mean, I guess. Oh, I see Hannes in the queue to talk about it, but I think I wonder if we should hum at this point, because I guess unless Hannes is about to make a very impassioned case.
Yeah, I think it's not for me. It's not terribly inconvenient. It's just I need to define a separate extension for 1.2, and then that means a few more bytes over the wire, extra code, but only a little bit. So it's not. It's definitely not the end of the world. So I wouldn't die for this.
So I guess we should do we need to do a hum if the person that was asking the question isn't willing to fall on a sword? I'm thinking that we should basically just leave it as is.
Definitely works for me.
Okay, let's go ahead and note that. Thank you. And thanks, Hannes, for being pragmatic.
Okay, so that's the third and last issue that I know about, which leaves us with the question if there are any other issues. Okay,
I think if there are, we can discuss them on the list.
Yeah.
So in the interest of time, I think we should move forward to the next presentation, which is DTLS 1.3.
Okay, so I'll stop the slideshow.
Thanks, Ralph.
What it present? Which button is that again? Is it the one that says presentation
The
view?
paper button.
The paper button.
Right next to joining the queue.
Oh, okay. How did I not recognize that? Okay. Well, can I talk multiples? No, I can only share one. Okay. That would have been awesome. Obviously, I've declared like temporary bankruptcy on 8446 bis. I just wanted to, I still plan to work on it. I preparing for this meeting, I went through a bunch of the comments David Benjamin had and realized that I was not able to produce useful discussion in the time I had available, and so I'm planning to do that. But I didn't see any point in requiring us to discuss it when I wasn't prepared to say anything meaningful. Next slide, please. No, it's me, isn't it? That's right.
You can.
Okay. Yeah, I just did that. It's not used to be. Not used to having that control. So, the status of details 1.3 is that we're on 48, but we've had 2 substantive issues raised that we thought we had to deal with, and so this is hoping to get this issue dealt with as fast as possible, and then get this out the door. So the first substantive issue was raised by John Metzen, which is that because GTLS has much tighter record limits than TLS for AES-GCM, due to the fact that forgery, that MAC failure does not cause connection teardown. Then, as a practical matter, you have to rekey very often in order to deal with the key extraction. But the epochs are only 16 bits, which means that the total number of records you can actually send is only about 2 to the 40th, which is really quite a small number and concerning. So that seems like not. It's worth noting that that this is also a problem with GTLS 1.2. It's just that we didn't actually write anything about the key record limits in GTLS 1.2. So we're trying to be more rigid about 1.3. So we have 2 proposals in front of us that both kind of are relatively similar. One by Chris Wood and one by myself, though I don't think Chris and I are fighting about this. We just decided to try to flesh both of them out so people could see them. The first is to expand the epoch to 64 bits, which you have to do in any case, so that you can rekey more than 16 times. And so the question is what to do with the key formatting for the AEAD. So one option is to just encode the lower 16 bits in the nonce. So the nonce would be, still be 16 bits of epoch and 48 bits of record identifier. This obviously requires you to spend the ACT to 112 bits to incorporate the entire epoch, but it's still the same. Underlying formatting for the details records. So that's more consistent with GTLS 1.2. The other option is to expand the sequence number to 64 bits, use the entire sequence number in the nonce, and just remove the epoch entirely. I think the argument to try to argue for one or the other. The argument I think for the 255 is it's a simpler change, and you still have the epoch you still have the lower 16 bits of the epoch in the nonce. But when you go to look at the analysis about the situation, you say, well, what is the epoch doing in the nonce anyway? And to be honest, this really, really old. It was done when we first did GTLS, and I'm not sure we had a good reason. But to the extent to which you're thinking about this problem anyway, if you're worried about the epoch allowing you to distinguish between different key phases, well, now you have to worry about cycling around to the 16. And so it's not clear it actually helps. And so what you're really saying is, and so when we went to the analysis, we actually said each epoch has to have separate keys, and that's what's giving you separation between the epochs, not having the epoch bit in the nonce. So the argument for 257 is, once we had to accept that the keys had to be separate anyway, which they already are, and we were depending on that property, then it didn't matter what was in the nonce. And this allows you to have 264 possible sequence numbers if you had a ciphers permitted that, and B, it looks more like the TLS 1.3, so it harmonized to TLS 1.3 instead of being some special GTLS sauce. So that's what we were thinking about when we did it. When I posed this, I think in either case, I'm going to want to run this by a couple some cartographers, but we can do that quite quickly once we have this written down. And we already did run by the 255 by Karthik. I think seeing Scott Floor's comments. My impression is because we're also randomizing, because we randomize the sequence numbers, we have the XOR against the epoch. As Martin was saying, yeah, I don't think that actually makes as much difference as you think. So I guess I think I prefer 257. I think that being closer to TLS 1.3 is better than being closer to DTLS 1.2 in this case. I think and it leaves us with this sort of weird wart where we have like half of it there, and we have to reason about it. So I guess what other people think? I saw MT was suggesting that he thinks 257 is better. Okay, Nick says okay. Anybody want to argue for 255? Okay, then I will refine 257. I will run it quickly by some of the usual suspects, and we will call it soup. Okay, next. So this is something Dave Benjamin raised, that the because the DTLS handshake structure is different from the TLS handshake structure, and it has these three fields that are used for reconstruction of the handshake, of the fragment handshake messages. And so then the question becomes like, and so like if you like ordinarily you would say the transcript like consists, and so even when you reconstruct the messages, what you do is you instead of basically saying we didn't need this framing, what you do is you basically set the message sequence number to be what it's supposed to be, and then you set the fragment offset and the fragment length to be like 0 and the length of the message, right? And so so these are fixed values, but they still go in the transcript currently. And Dave Benjamin pointed out that this like is a little weird in the message hash that we use for for HRR. And he also pointed out that in this case, it's not entirely clear that you can convince yourself that TLS 1.3 and DTLS 1.3 transcripts like don't overlap in some way, because this sequence number and stuff is overlapping with message contents. I think David sort of said like, well, this is just annoying and grumpy, but we should like live with it. But I actually am wondering if, in line with the previous thing, we should just bite the bullet and like say that the DTLS message transcript does not include these 8 octets, and then it would look the same as the TLS 1.3 message transcript. So I think like I don't think there's much hard. I think this would not be harder for us in any meaningful way. I don't think it's hard for anybody else. I know it's a late breaking change, but I guess like because we had to do something. David points out we have to do something here because we have to at least specify what goes in message hash. And so once we're doing that, maybe we should just like live with it and make the change. People are probably getting the impression I'm like trying to eliminate any distinction between DTLS and TLS 1.3 when I can. I will say like the reconstruction code has to like, it's not like just to people on the same page, like the reconstruction code like has to like assemble messages anyway. So it's not like you're like not having to screw around with these fields. David, MT, Chris.
Yeah, that sounds pretty reasonable. I don't have any concerns, given especially the point that Martin points out in the chat. So perhaps we can work with David to prepare a PR, and here he is. I don't know if he wants to say something more. David, go ahead.
Sorry, it's been a while since I've used this thing, so I forgot which buttons to press. Yeah, so I guess I think when I filed the issue, I thought it would be kind of annoying to change it around. I mean, I originally filed it just because it was like ambiguously specified and I wasn't sure which one it was supposed to be. But I guess it's true that the only like by the time the only message is only the first client hello that ever is in this like ambiguous state. So and at that point you haven't even picked the hash yet, so you could just like keep the client hello around and just sort of like erase the extra bytes as needed. So maybe it's okay. It also like we also don't strictly need them to be separable if like, well, I'm not sure. I suspect we don't strictly need them to be separable if all the labels say DTLS rather than TLS, but it is like kind of annoying to have to remember to do that like every time. So. Okay.
So I'll prepare for this. And if someone, given that it's going to take us a couple of weeks to like, finish the other thing, like, if someone could try implementing this and make sure it doesn't like make things explode, that'd be great. I don't think, by the way, you have to keep the client hello around very long. Just to Hannes's comment. I mean, like you do the version negotiation immediately. So like, so you already know what you're doing it. Okay. I am done.
In the repo, there's also this pull request to address, to reference RFC 7457, which is the Utah draft. I think that I definitely think that it's not needed. I think you didn't either. Does there anyone want to speak to adding that as a reference? Because otherwise, I think you should just go ahead and close the PR.
I was probably close to PR.
Okay.
Get off the mic.
Implementation report. Who is going to be giving the ECH implementation report?
Okay, I think we're all set. Echo, I'll take the slides away and then pop up ECH. Sean, I'm going to mute you as well, if that's okay.
Oops, sorry.
No worries. Okay, this is a fairly quick update on encrypted client hello. I guess a quick primer for those of you who are not familiar with the protocol. Imagine you had a normal TLS 1.3 connection in which you're connecting to a server, revealing in the SNI extension potentially sensitive information about what you're doing, specifically what server you're connecting to. ECH, as the name suggests, is just a mechanism for encrypting that information to the target server that you're eventually trying to connect to, such that passive eavesdroppers on the wire between client and server can't figure out any of that potentially sensitive information beyond the SNI. Other extensions in the future might be sensitive. ALPN, for example, might be something you'd like to hide. PSK identities, that sort of thing. Since the last IETF, we sort of declared draft 13 as the interop and deployment target to get some initial experience, to avoid sort of circling on issues that we had open, particularly around, what is the right mechanism for signaling acceptance versus rejection? How do you deal with HRR in Greece? Practically speaking, how you would implement server-side padding for the purposes of hiding, which certificate was actually chosen for the particular connection. And there's also been other questions around extensibility in the ECH configuration that's published in the HTTPS record. We've parked all of those open issues and labeled them as such in GitHub, with the plan being to effectively get some experimentation, experience under our belts, and then revisit these based on that experience to have a more informed decision about how complicated this thing is to actually do in practice, how feasible it is, and so on. There are a number of implementations out there right now, OpenSSL, Forks, NSS, and so on. Some of these are interoperable with others. Others are, working their ways up towards draft 13, which is good. If you know of other implementations, request that you please add it to the wiki. You can find the wiki page under the ESNI or ECH repository on GitHub. If you can't find it, just drop me or the list a message asking for it, and we can point in the right direction. But the link in the slides also should work as well. During the course of bringing up the different implementations, and other people have sort of been taking notes in terms of, what are some of the pain points in the protocol right now. Things to note going forward to potentially revisit depending on you know, how severe or how painful these sharp edges happen to be. You know, for example, configuring your stack such that things from DNS are plumbed into the TLS stack accordingly and parsed and validated in the right way has been somewhat annoying. There's the required text for checking the public name in the ECH config inside the TLS stack, which requires, you know, an IP address parser, which typically was, or previously was not a requirement for most TLS stacks. So I mean, what's currently in the draft right now is not the best in terms of the technical procedure for validating that particular ECH config. So it's no surprise that this became somewhat of a pain point when implementing things. Perhaps we can do something in the future to fix it, but you know, something to be mindful of if you're going to spin up an implementation of your own. Also been noted by several people that split mode is kind of challenging to deal with as well. Not aware of any experiments or deployments that are planning on using split mode right now. But if there are folks who do specifically try to implement this use case, it'd be very good to know what sort of obstacles you run into, specifically around coordination between the front end and the client-facing server and the backend server. Similar to the implementation interop wiki, there's a wiki page for sort of tracking these red flags with these sharp edges. It would be useful. I think it would be useful for our posterity's sake if we started accumulating these collectively, just so we can be mindful of potentially ways to simplify the specification going forward, or areas we might expand upon in the draft in an appendix or what have you, for the purposes of helping implementers, similar to what's in the RFC 8446. Stephen, do you have a question, or did you want to elaborate on anything?
Yeah, just on the split mode thing. Split mode itself was pretty straightforward. You just required a new API, but it was easy enough. It's split node plus HRR that was the problem, and the issue was in particular with HA proxy. You either operate as a kind of a TLS endpoint in non-split mode, or in what they call basically a TCP mode is what they call it, where they're trying to go faster stripes essentially. And in that mode, they only look at the first packet. So I don't know if there's any way to fix the issue that with HRR, you have to change the second packet as well as the first one. But on the other hand, it's presumably when HRR might happen more often. So it might indicate that what we're doing with HRR is less likely to be of real interest in the real world. I don't know. But it was it's with HRR that was problematic. The basic split mode was pretty straightforward.
Okay, yeah, thanks for clarifying. No surprise that HRR is problematic, I guess. I think you also raised an interesting point in that this was particular to a specific server implementation, HA proxy. It'd be interesting to know as people are integrating ECH as it exists in various TLS stacks like Boring SSL or what have you into different server implementations. What pain points come up along the way. Similarly for clients, how challenging is it or not to plumb this into curl if you were to extend curl to add support for this, or to browsers or what have you. Stephen?
Yeah, sorry, you reminded me of something I meant to say there, which is it's not on the list. I think it's on the wiki page though. Is that with curl, one of the big issues is going to be supporting SVCB. It's not ECH per se that's tricky. It's all the DNS handling and caching that might go around that I think would be a giant piece of work for curl.
Yeah, good point. Thank you. Ben?
Hey, so SSL stacks generally, general purpose SSL stacks have to have IP address parsing to be able to do certificate validation for IP certificates. Is my audio incomprehensible?
It's a little bit choppy, but so I'm just trying to piece it together. I believe I heard you though.
Okay. So yeah, why? I guess I'm I was curious if you had more insight into why all the IP address parsing code for IP certificate validation didn't make this easy.
Well, we recommend a particular parser, the WhatWG parser, in the draft, if I recall correctly. And I don't know offhand if that matches the existing parsers that are present in existing TLS stacks or elsewhere in host stacks. So it's mainly, I guess, a problem of ensuring parity between what's available and what's expected from the perspective of VCH. And as you may recall, trying to carve out specifically in language what is considered to be a valid or not public name. The world would be, I guess, a lot simpler if we did not have to deal with this IPv4 nonsense. But alas, here we are. I don't remember any more particular details beyond that. Okay, go ahead, David.
So the WebWave parser did also recently change in a way that's actually probably useful to us because we realized that if you really want DNS names to be closed under under suffixes, and so we can instead simplify our rule to if the last component is all numeric or looks like hex, then reject it, which should be a lot simpler than the go check for 4 components or 3 components insanity that we previously had to deal with.
Right. Yeah, I didn't know that. Thanks for flagging that. It might be good. It might be useful to track that. I guess I don't think that would require a spec change, provided that you just implement the latest version of the WhatWG parser. But anyways, good to know. Stephen?
Yeah, I mean, I only just noticed the title of the slide here. I think we should. There's some reasonably good news too. I think actually, because although ECH is a lot more complicated internally than ESNI, externally for all the web servers we've integrated with, it was really easy to upgrade them from ESNI to ECH. And we got a drop with I think Mozilla for draft 10 and with Boring for 13 without too much hassle, and with Cloudflare as well. I'm not sure what on 13. So I think there's quite a bit of good news as well as red flags. More good news than red.
Yeah, sorry, I didn't mean to cast doubt on sort of the future of ECH, but mostly just to point out the few implementation sharp edges that have come up. It is good news, indeed, that it's been relatively easy to upgrade existing servers to support ECH, as you say. It'd be great if this list was empty, but can't have it all, I guess. All right, that's pretty much it. Between now and I guess IETF 113, I guess the expectation is still we're still targeting draft 13 for interoperable deployment. And as client stacks, server stacks, proceed in adding more support for this, we should have a better picture in terms of how deployable ECH is on the internet at that meeting. Any questions? If not, I will yield the floor and we can turn it over. I think Stephen, you're next. No, sorry, Joe, you're next for A447. I'll stop.
Okay, here we are again. So this is going to be a little bit of a rehash of some of the discussion we had in the flags spec. So in RFC 8447, we have this recommended column, which is supposed to indicate, okay, if it's yes, then this is an extension or a parameter that's generally recommended for an implementation to support. And if it's no, it means it's not generally recommended for an implementation support to support. So on the surface, this seemed like a good idea, so that, you know, there were certain ciphers that we thought were good, and then others which we hadn't evaluated or we might think were bad, that we didn't recommend or were useful only in particular circumstances, or could only be thought of as secure in particular circumstances. The feedback that we got from here is that, well, this isn't really perhaps enough information. You know, N could mean a number of different things, from what, hey, it was not evaluated by us, it was not recommended in any circumstances, this cipher is not safe at any speed, can't, you know, you should not use it. Or could mean that it's only recommended in specific cases. So as we're working on RFC 8447 BIS, we'd like to try to address this issue and make it a bit clearer, which probably means adding some additional states in here, I guess you'd say. So we have a draft out, and we have a proposal in that draft that we'd like to run by the working group here and get some feedback on. The proposal is parameters, you know, if it's yes, and we can argue about what the character here is, but yet Y right now would mean parameters are recommended for general use as it is today, and then N would mean that they're discouraged. And then we would also include a reference there that to the document that says why this parameter is limited. And then if the area was blank, if there was a space there, then parameters would be unevaluated. So they would in general be not recommended, but we wouldn't have any specific thing to say about why, other than it's just we haven't gone to the work. So Martin.
So I was looking at this, and it sort of occurred to me that this column is really, what does the IETF think about this code point? And if you frame it that way, then maybe the title of the column is, you know, IETF status, and the values are recommended, discouraged, or, you know, no opinion. And that gives you the opportunity to have some statements there about other things if the IETF wants to say something else, like limited applicability or something else. I don't know. Can we just say what we mean?
Yeah, that's a good suggestion. Next, Stephen.
Yeah, I'm going to maybe argue the opposite. I think the semantics of no can't be defined precisely, and therefore has to be vague. And I think we can't do any better, really, because sometimes no means maybe it'll be good in the future, and sometimes no means we absolutely hate this, and sometimes no means this is something that somebody else thinks is good, but we have no opinion on. If we try and get any more fine-grained, I think we're on a slippery slope, and I don't think it'll work. So I would argue for the status quo, even if some people find it difficult. Sometimes life is difficult.
Ecker?
Yeah, I guess I'm persuaded. I think that we need to have something more fancy than we have now. I think that like what we have now is innovation, and that like it, you know, it avoided us having to like spend an enormous amount of time evaluating things we didn't care about. But I think it's also clear people are confused. I think Martin's suggestion is actually pretty solid. I don't care what things are called, but I think that I think the minimum things we need to be able to say are, we're in favor of this, we think this is bad, and we have no opinion about it. And those are the minimum things we have to say. And I think there's like room for, here was some nuanced opinion, like that maybe is only good for IoT or something. So I think, you know, and I think it's clear that the YN thing didn't really work out that well, specifically. So I think MT's proposal will be fine. You know, I think we probably should just strike the Y in the end.
Okay. Stephen?
Yeah, sorry for getting back into you again. Honestly, I think no opinion versus bad involves almost as many debates that are pointless as the previous situation. And so I don't think that's going to solve it for us, and I don't think it really makes it much clearer for somebody who's going to be confused anyway. So I think let's confuse them a bit.
Okay, Yoav?
Right, so these kind of values make sense for cipher suites or for I don't know Diffie-Hellman groups. Like yeah, we really like the 512-bit 521-bit EDDSA, but this is a yes, and the 512-bit RSA is no, and we're not saying anything about the brain pool curves. That makes sense, but for extensions, what possible extension are you going to say, no, don't use that extension, standardized it, we just added this. So it might be a change that we make later to this extension, but don't see how we're making new extensions and making them not recommended with these semantics.
Answer that question. The ones that have come up before typically do not get adopted by the working group, and then they go to the ISE to get published. But what I got on the queue to say was that instead of having an open-ended section where we could put it in this column, we could also just put notes in the actual registry and point so that there's less ASCII art problems.
Okay, Rich?
Yeah, I thought I heard Stephen say he was against having a no, and I think we need that for when we have yet another die RFC that says don't use these ciphers. Okay, it wasn't Stephen, it was somebody else I thought said no. I think notes as one of the designated experts is a slippery slope. Where do we get the note text from? I wouldn't want to write it, and I also wouldn't want to copy it blindly from some ISE draft. That's it.
John?
For any standards draft, I think it would be good with a text column to complement this yes, no reference. That could, for example, explain what any limitations would be, or, for example, a specific use case. This is recommended for IoT and so on. That's similar to what IPsec is doing today, at least in their drafts. But I think that should only be used for standards track, not for any individual registrations.
Okay, Rich?
Sorry, I meant to take my hand down. But in the chat, I think it was Watson proposed having a D for deprecated, and maybe that's a finer grain than N. Don't know.
Ben?
Hi. So yeah, the concept of freeform notes seems pretty strange because it seems like a lot of the places where we want these notes are on ISE submissions, and so we, I guess, be in the position of writing an IETF standards track RFC that adds a comment to an entry created by an ISE submission. It seems at best hostile and also pretty complicated. I think that, in terms of deprecated, remember that we can also remove code points from the registry. Not that they be free again, they just get marked as reserved due to collision. Or we have various ways that we could potentially notate that independent of this. I think what might be most straightforward and clear would be to simply note the status of the declining document in the registry. So if we're allowing code points to be registered from documents that are independent stream or standards track or experimental, let's just have a column that tells you the status of the accompanying document.
So speaking just for myself, Joe, what I like about this is that it doesn't take a lot of IETF arcane process interpretation to parse those words, even if we want to put a little more nuance in it. So I think we may need some finesse, but top line, I like this the starting point of just the clarity of what that might mean to someone that's not steeped in IETF process. And back to kind of your comment, Ben, that you previously made to list kind of status. I think that's helpful for inside baseball for IETF, but the nuance of what's in ISC versus kind of someplace else, that's not so well appreciated. That's just for us.
Yeah. Okay, great. This is good feedback. I think we're also going to present this at SAG. We may do a little revision of this based on some of the feedback we got here, because this is something that may be of interest in general to other groups that face similar challenges. There are a couple other things in this draft that I want to quickly go through here. The other thing we had added was a way to reserve experimental code point range that we kind of set aside a temporary space where we could assign values that were valid for only a year for kind of larger scale experiments. I think, you know, after some discussion, this really probably would be better not trying to manage a space separately from IANA, but kind of go through the existing IANA process and maybe see if we can streamline that a bit. I don't know if anybody has any feedback on that particular area. Go ahead, Martin.
So I think this is a good direction. The idea that we give someone a experiment with and the experiment turns into success, and then they have to pick a different code point and deal with the deployment hazard that come from that is kind of annoying. At the same time, having the entire space available for experimentation, perhaps with a process that streamlines the registration would be a good thing. I think we want to encourage people to register the code points that they're going to use and keep that as simple as possible. This seems right.
Rich. Yep, well, you're on mute, I believe.
So you got to see my face. I don't think the registration is overly complex. I mean, sometimes you have to wait, you know, via email delay for one of the experts to respond. But, you know, it's only like a week or two in general. And no experiment that lasts a year is really going to be offset by a week. You can always pre-allocate, ask for a pre-allocation. I'm just mainly concerned about the, you know, 2 places to go for things. And the minute you have to write down information in 2 places, you're almost guaranteed that somewhere it's going to be out of sync, right? The old comment about code and comments disagreeing. Expiration date, yeah, I'm in favor of that. You know, make it renewable a couple of years. Okay.
All right. So I think for this draft, we'd like to do an adoption call after this meeting. There'll still be some things probably to work out in some of these details, but that's it. Thanks.
Yeah, thanks, Joe. That sounds reasonable to me. I know there's been some discussion about this on the list. There's been interest in doing this for sort of a while. So I guess the question that we'll ask the list is if what's in the document right now, pending the changes that were discussed in the last 15 minutes, is it a reasonable starting point for updating 8447? So I'll work with Joe and Sean to get the document updated, and then we can start an adoption call on the list. All right. I believe now then this, unless anyone had any questions or concerns about that, I believe now we're over to Stephen. So Stephen, you can request to share slides, and then I will, if you have them. If you don't, that's
fine. So I'm just putting that there was 2 drafts I had back when ETH was the SNI, and I'm just, this is kind of a heads up and to get some feedback. I'm proposing to maybe refresh these with a general substitution of ESNI for ECH. And then I think last time we talked about this a couple of years ago, people seemed like okay with maybe adopting them, but we didn't do an adoption call. So I'd hope to get back to that state pretty quick. The text could go into ECH as an appendix or something, that'll be fine. The first one basically just defines a PEM format for a private key and an ECH config. And that's really useful for loading into a server when you want to have multiple keys supported. So you load one file for ECH config plus private key pair, and then you can load a whole directory of them or do various things. And it's just a PEM file format. The second one is a well-known URI, and last time I did it, I found it very useful to be able to have a web server publish its ECH config so that a DNS process could pick it up and then publish it if you're refreshing keys. So that was the well-known URI one. So that's what I propose doing. I'd love to get any feedback. I'm happy to do that in the next little while and then see if the work group want to adopt them or not. But if people think this is really not a good idea anymore, then I'd like to know that now before I do anything. That's all I have. Edgar.
The PEM thing seems harmless, but I don't think it needs to be specified here. It's a PEM file. So no, I don't think we should adopt that. The other thing, I guess I don't know yet until I know whether or not anybody who deploys DNS would be interested in it. If they do, then I think we could. Then I think the question would be, I'd ask our IDs where the appropriate place is, because it's not like a TLS thing in particular. So it's not clear to me it belongs here if that's the case. But I guess the question would be, like, I mean, no particular, like it's like EPP or something, right? It's like, so I guess, I would defer, I guess, like, the answer I'm trying to give is if people are interested, then I think someone should do it, and I would refer to the ISG as where it should go.
Sure. I mean, but I guess I think the parent format would make most sense here because we're defining ECH config. It's a fair point about the other one. I think, I think if you have dynamic DNS, you wouldn't need that well-known ESI thing at all. If you don't have dynamic DNS and you have some other zone production mechanism that feeds into a zone file that gets DNSSEC signed or whatever, then in our experience it was kind of handy. But I guess you could argue it should be defined somewhere else for sure, yeah, like DNSL or whatever.
Right. I mean, yeah, that's what I'm suggesting. I mean, just to be clear, I'm opposing taking the PEM thing.
You're opposing it?
Yes, I don't think we should take
it. So I don't understand why.
Because I don't think we need to specify it here. I think it's fine as an internet draft.
Okay, I don't follow, but
I mean, we don't. It's not. It's simply not in scope for this working group.
Okay, I still don't follow, but we can. I mean, we're probably, that's enough time for this item. Probably we can talk about it on the list, I guess.
Sure.
So that's all I had, unless the chairs want to devote more time to this.
Yeah, thanks, Stephen. So yeah, I mean, you went away, but quickly, if you can come back, how much work do you think it would be to update to ECH for either of these?
Not much. It's just a case of getting around to it. So I could probably get it done in the next couple of weeks.
Yeah, I think if you're able to spend some cycles on it, just updating it, and then we can talk with the chairs, or I can talk with the other chairs to see, you know, whether or not this is something we want to, you know, actively pursue here or elsewhere. It does seem like there's some interest in at least the well-known draft. Whether that's TLS or not, I don't think it's a big concern. I guess same for the PAM format as well. I don't know specifically where it needs to be, but it does seem that there's at least some interest in it. So all that is to say, we'll chat offline and come back with a proposal for how to move it forward.
Sure, I'll resubmit the drafts and talk to the chairs and we go from there. Thanks.
All right. Yep. Thank you, Stephen. Okay. Next up on the agenda is, I believe, the pseudorandom CTLS extension. Ben, that's you? Okay. And I will let you take it away.
Hi, I don't see the slides in the slide collection.
Oh, they're not there?
So I'll take another.
I see.
Export authenticators, share slides, ECH, zero knowledge proofs. It's okay. So I will try to present from my own screen instead.
Oh, sorry. I must have skipped over this one when I was importing things. Hold on, it's processing right now.
Oh, okay.
That's my bad. One moment. Okay, can you give
Is
it another
my
shot?
audio still crummy?
No. It might have been just me. You sound fine now.
Okay.
Grant.
Okay, great.
Sorry about that. Take it away.
So hi all. This is a 0-0 draft. This is the first time we're talking about this draft. The authors are myself and Chris Patton, who's also here. And this is intended status experimental. So this is new stuff, weird stuff. So what are we talking about? We are talking about an experimental extension for CTLS. So CTLS, that's the also relatively new, still in under development version of TLS that has a pre-shared template that the client and server somehow agree on out of band before they attempt the connection. There's an extension to that that makes the wire image purely pseudo-random. In other words, it makes all of the transport contents pure pseudo-random bytes. So this is possible because we have a template and because CTLS already has essentially an unpredictable wire format, where the wire format varies in arbitrary ways depending on the contents of the template. That's very different, of course, from mainline TLS 1.2 or 1.3 that has a very deliberately, carefully structured wire image. This extension sits between CTLS and the transport. So the transport, like TCP or UDP, is not modified, and CTLS is also not modified. This is layered between them, with the goal basically of simplifying security analysis. So all the security analysis that holds for TLS or CTLS should, for the most part, continue to hold. Why might you want such a thing? There's a security benefit here. So there are these attacks called the NAT slipstream attacks, and also various other protocol confusion or middle box confusion attacks, where one party causes the other party to emit text on the emit bytes on the wire that are confusing to a badly written parser in the middle. So that's one cause for concern. There's also a privacy benefit here because each CTLS template results in a different wire image, CTLS reveals which template is in use normally. But this extension causes all CTLS templates that use this extension to be indistinguishable on the wire. There's a protocol agility benefit because if the wire format is fully encrypted, then only authorized parties, or at least only parties with specific knowledge of this protocol, will be parsing it. So the current model that we've spec'd out in our draft is based on something called a strong tweakable pseudo-random permutation, or sometimes in the literature this is called a tweakable super pseudo-random permutation, or a wide block cipher, or variable input length block cipher. There's a lot of different terminology around this, but it's fundamentally just a slightly trickier cipher mode, like the usual block cipher modes, like AES CBC, but more complicated. And it gives you one really big block cipher. Our extension takes that and applies it to any TLS messages that are plain text, that aren't already ciphertext, and also then to segments that contain both the headers, which are clear text, and at least 16 bytes of the ciphertext. We chose this setup because it has no ciphertext expansion, it has 0 space overhead. So the output and the input are exactly the same size. And we believe, and hope to be able to prove, that it is still very highly secure. In particular, it relies on TLS's integrity checks. So any modification to any part of the bit stream will cause TLS's integrity checks to fail. So this is just a quick outline of what we're talking about here. This is a diagram of a typical CTLS stream. So you've got a handshake message like a client hello. That can be fragmented, especially in a DTLS style situation, into multiple fragments, handshake fragments, which are then prefixed with headers and sent to the other party. And then eventually when the handshake is over, the bytes that follow those handshake messages are AEAD ciphertext output. So they're already pseudo-random. So in our extension, we take 2 steps. First, we use this STPRP, the cipher, to render the handshake message itself pseudo-random before it's fragmented. I'll note that this cipher, this STPRP, takes a key and a tweak. Tweak is a little bit like a nonce, but we don't actually require it to be non-repeating. It's a key diversification input. So first, we encipher the handshake message, rendering it pseudo-random and only decipherable to a party that knows the key. And then, as a second step, we do the same thing to a block containing each header and a little bit of the subsequent ciphertext. We rely on the fact that every message includes at least 16 bytes of ciphertext payload because that's the smallest AEAD output. And so the resulting stream here at the bottom is composed of lots of different kinds of output, but all of the outputs are pseudo-random. So this is very early days. We are seeking working group input. Most importantly, I think, on the cryptographic construction here. So we've chosen STPRP for this draft, but there are a lot of other options here with different trade-offs in terms of simplicity of description and also how complicated the analysis is, especially under active attack assumptions. And we're also looking for input on how to integrate this with CTLS in the way that's cleanest, in the way that enables broadest use. We do have some requested changes to CTLS itself. So I sent an email a few weeks ago with a bunch of input based on based on this work, things that could change in CTLS that would make it clearer in general, or that would make this extension easier. And we do hope to pursue working group adoption at some point, but I think right now, really the question is, what would you like to see in a version of this that was ready for adoption? So that's all I have for slides. Welcome any thoughts from the working group. Jonathan Lennox, I assume you're in.
Yes, I was just going to say I don't think this prevents net slipstream because insofar as the server can force, the server obviously knows the key stream, and can insofar as they can get a select what the client sends as plain text, they can therefore select what gets sent as ciphertext, which is what you need for net slipstream.
That's interesting. I'm going
We
to
had
have
this discussion.
to think
We had a discussion earlier today in web transport where we have this might be a problem for all of Quick too. So this might be, but yeah. So basically, because the key the key stream in advance, you can just say, okay, send me this. Take the ciphertext you want, XOR it with the key stream, tell the client to send that, and that's your net slipstream attack.
That's a very interesting observation. I think that we had been thinking about this principally in the handshake messages, where there's clear client provided, or rather, source provided entropy. Each side is providing their own entropy there. You're right. That gets harder in the body of the stream. So we'll have to give that some more thought. Thanks for noting that. Ecker?
This is quite fancy and interesting. Those are independent observations, not one. I mean, I'm not sure I think of the not split streaming. I guess, obviously, if we're going to expand the data, then it's sort of about not split streaming. Depending on how this construction actually works, it may be quite inconvenient to construct the appropriate ciphertext. Because as I recall, you're partly depending on the because the EAD because the authentication tag is random, and the authentication tag then becomes input to the PRP. Then it may be the case that you have to essentially iterate through a large number of plain text in order to get a ciphertext of choice. But I wouldn't be willing to guarantee that because I don't understand the construction well enough. So I guess one thing I should question about that I'm not sure I understand is, does this mean that a server if a server supports multiple profiles, it is then required to trial decrypt in order to determine which profile the client is using?
That's so mostly no. If all of the profiles share the same key, then you can have distinct profiles and still demultiplex them.
Right. Although we take the suggestion in the Jabber that the key material should depend on the profile as well, that will no longer work.
That's right. The key material deliberately, the decryption process deliberately is profile independent.
Okay.
For that reason.
Okay. Right. Oh, well, sorry. Yeah. I think so. I think the question would then be: is it required to? Is a security reason to have the? So I mean, you just see the Jabber. Paul Grubbs is saying sharing keys makes analysis difficult. So I don't know, but like that, I'm not sure it's a disaster to have the trial decrypt, but I just wanted to flush that out a little bit.
Yeah.
Anyway, this is
actually the thing that worries me more is it's not clear that trial decryption is possible because there's no MAC. Specifically on handshake messages, the handshake doesn't contain its own MAC. We haven't added a MAC, so how do you trial decrypt?
Yeah, fair enough.
That's one of the open questions here.
That's an excellent point, right? I mean, right, and since CTLs are trying to make it smaller, right? MAC is unfortunate. Anyway, I think this is pretty interesting. We've been discussing exactly what we need to get CTLs to the line too. So, I think I guess what I'd like to see before we think about adopting is enough harmonization with CTLS, which may mean the changes you propose. Because I apologize, not having reviewed that we have confidence that we're not fighting with not fighting each other, right?
Yeah, obviously this is early days. We don't have anything. We haven't attempted an implementation, so
right. Well, the other thing, I think I want to see is, I was surprised not to see this in the specification, but I may just not run out of time, is at least one concrete proposal for the STPRP. Because like when I read the specification, I was kind of like, well, we just don't define one. So I think like I'd like to see a definition for one, even if it wasn't great. I think that would be another thing I want to see. But maybe I'm actually just ran out of time, right?
So I see my co-author in the queue. Maybe I'll let him. Maybe I'll let Chris chime in on that topic.
Great.
Chris, were you responding to Ecker's point there?
I can go away from Chris.
Well, I don't hear anything from Chris. So Stephen, go ahead.
Okay.
My mic was off. Go ahead, Stephen. I was just saying you're first in the queue, so go ahead.
Okay, so I would encourage further work on this. I think it's interesting. I really like how many people this will annoy. I would encourage you to maybe think about this as a way of kind of pushing the envelope and breaking things for a while at least. And see if you did all this and succeeded, even ignoring some of the security goals, what would you break? It would be interesting to learn that. And then last comment is, I think as this, if you assume this kind of eventually reaches maturity, maybe the stage we want it to be mature is not to have one fixed way of doing it, but many, many ways that are malleable even after the standard has been produced in an RFC. Because the adversary in this kind of context is probably pretty good at changing themselves as well. So maybe think about the eventual outcome not being just a fixed, single, interoperable way of doing it, but more of a way that you can keep changing what you do. And I like it. So good work.
Thank you.
Thanks, Stephen. Yeah. So about the STPRP construction, so we were going back and forth about this because like we were wondering if this is something that the CFRG is supposed to do, or like could we specify our own construction? There's lots of options in the literature that I think work really well, and all you really need is AES. So I'd be happy to stick a construction in the document. But yeah, I guess the question is like where should that live?
Yeah, so before I guess talking about particular constructions and whatnot, it might be useful to try to identify what are the requirements of the thing that you need. It had been mentioned that you need non-malleability, but not CCA security. Is that necessarily true? I don't know. An answer to the requirements question could be useful in helping shape what the actual construction you end up with at the end.
I think that's true. I think that the very informal idea is by tampering with the bits on the wire, you can't predict, an adversary can't predict how it impacts what is deciphered and how the server like interprets the handshake. So the idea is that like that should cause you can probably talk about the probability that it leads to a handshake failure. But you're right, like we haven't really worked this out. Like Ben said, this is super early.
Ecker?
Yeah, so I would think like for the moment, it sounds like the construction is pretty simple. So I would just like pick one you like and kind of like cite a reference and stuff in an appendix or like something. I mean, there's just like they give a complete specification, right? So that'd be my point, and then like I think just hold that loosely.
Yeah, I think we'll do that pretty soon. Maybe after the next CTLS iteration. Scott?
I would, if you're talking about which STPRP you want to use, well, once it's up to you to decide what are the security properties you need from it. But once you do it, it really, that's what the CFRG is there for. You really should go to them and saying, gee, here's what we need. What do you recommend?
I agree. I think that we ultimately we would not really progress to publication without probably a CFRG approved underlying construction. Okay, thank you.
Right. Thanks, Ben. Paul, you're up. If you could request to share slides.
Yeah. So okay, I'm sharing my.
Sorry,
Share.
We discussed this already.
Yeah. Hi everyone. Can you see my my desktop here?
Can see the desktop. I'll let you know when we see the full screen slides. All right, we can see them now. Take it away.
Okay, great. Okay, thanks, Chris. So today I'm going to be talking about zero knowledge proofs meets TLS. So I'd like to, well, sorry, first I'd like to say that this is based on joint work with Arasu Arun, Joe Bonneau, Zach DeStefano, Mike Walfish, and Ye Zhang. And I'd like to start by just saying that I think TLS is pretty awesome. I'm a newcomer to this working group, but I've always been a big fan of the work that everyone here does. And I think I'd like to congratulate everyone here for getting a bunch of awesome crypto deployed on the internet, most notably TLS 1.3, which is an amazing protocol. And this, I think, is a great accomplishment for the working group to get this pushed into more and more places. However, I'd like to talk about the challenges that the increasing deployment of TLS is causing. And these challenges are so-called visibility challenges for network operators. Because network operators who are used to enforcing network policies by scanning plain text traffic directly. So an example of these policies would be like DNS filtering, data loss prevention, and enterprise networks, malware scanning, and the list goes on and on. There's a ton of these network security policies. So obviously, though, by design, TLS prevents the network from scanning the traffic and enforcing these policies. So this causes a challenge for network operators. And so these visibility challenges are pretty old, and even in the development of TLS 1.3, as far back as 2016, there was this famous, well, maybe some people consider it infamous thread on the TLS mailing list, in which a representative from the financial services industry came and requested that TLS 1.3 retain RSA key transport cipher suites because it makes the kind of like monitoring and policy enforcement that they need to do on their own traffic easier. And so this challenge still persists today, and there's lots of companies that have kind of sprung up to address these challenges with TLS 1.3. So I Googled last week and I found this Extra Hop company that is talking about security operations visibility for TLS 1.3. And interestingly, also NIST now has some kind of working group that specifically is focused on finding solutions to these kind of visibility problems with TLS 1.3. So the solution to these problems that exist in most systems today is to just not use TLS at all, or to terminate the connection in the network and just enforce scanning on plain text directly. So there have been some more fine-grained solutions proposed to these visibility problems. Probably the most mature is multi-context TLS, which changes the TLS record layer to allow different kind of contexts to have different keys, which some of which can be shared with the network or a middle box to allow them to kind of enforce policies in a more fine-grained way, but directly on plain texts. Other proposals are like enterprise TLS, or like ETS, which is a protocol that's kind of a variant of TLS that retains some properties of older TLS versions that make monitoring easier. And there are lots of proposals based on like trusted hardware, like SGX on the client or in the network. But all these solutions basically focus on keeping scanning and other kinds of network functionality in the network, but by weakening or modifying TLS. So today I'm just going to talk to you about zero-knowledge proofs, because I think zero-knowledge proofs are a really interesting set of tools for addressing these visibility challenges in a different way. Importantly, that doesn't require kind of weakening the security guarantees of TLS, nor does it require like modifying TLS, the protocol itself. So this discussion will mostly be centered on a recent paper that my co-authors and I wrote called Zero Knowledge of Middle Boxes. And I'll focus on a key contribution of this paper, which is an efficient zero knowledge protocol for decrypting TLS 1.3 records. Then I'll just speak kind of in general about future directions I see for zero knowledge proofs in TLS, and suggest some other open problems from our work. And then finally, I'll finish by soliciting some feedback and criticism, and hopefully maybe some suggestions for interesting applications of zero knowledge proofs to TLS. So first I'll talk about this recent work. But first I'll give just a very quick primer on zero knowledge proofs. So zero knowledge proof is a cryptographic primitive that's focused on allowing a prover to convince a verifier that a public statement, like for example, an arithmetic or a Boolean circuit, is true. So in the circuit sense, this would be that this circuit has a satisfying assignment. So the prover wants to convince the verifier that the statement is true without revealing why it knows that it's true. So zero knowledge proof is a string, like a bit string that the prover generates, and it'll send to the verifier. And the verifier can check this bit string along with this public statement. And by checking this bit string, it can gain an assurance that the prover knows why this public statement is true, but not why. So the zero knowledge proof kind of guarantees the verifier that the statement is true, but prevents the verifier from learning why the prover knows it's true. So for example, in the circuit case, the prover's knowledge could be something like a satisfying assignment to this circuit. So zero knowledge middle boxes use zero knowledge proofs to allow network operators to enforce security policies on traffic without decrypting it. So this addresses a lot of these visibility challenges, especially with things like filtering and scanning in traffic. So the way a zero knowledge middle box works is as follows. So when a client first joins the network, the middle box gives a description of the security policy to the client. Then the client, when it wants to make an outbound connection to a server, can just perform a normal handshake and establish a session key with that server. Then when the client wants to send some traffic, the client enforces the security policy locally on its own traffic, and additionally creates a zero knowledge proof that it enforced this policy correctly on its traffic. And so it sends the encrypted traffic as well as a zero knowledge proof that the underlying plain text is compliant with this policy. And finally, the middle box can verify this proof and block the traffic if the proof verification fails. So just to make this setting a little bit more concrete, I'll explain a use case from the paper that my co-authors and I wrote. So the use case is filtering DNS queries that are sent using either DNS over TLS or DNS over HTTPS, which are two increasingly deployed ways to encrypt DNS traffic. So in this case, the security policy would be basically a block list of websites that the client can't visit on the network. And so the client would, when they join the network, get a list of these websites, and then they would perform a normal TLS 1.3 handshake, as in the regular DOT or DOH protocol. And then when they want to send a DNS query encrypted, what they do is they encrypt the DNS query and send it, and then they include a zero knowledge proof that the underlying domain name in this DNS query is not on the block list. And so I want to reiterate here an important point, which is that this zero knowledge proof reveals nothing at all about the client's DNS query, except that the underlying domain name is not on the block list. And so finally, the middle box can block the DNS query if the proof doesn't verify it, that the domain name is not on the block list. So how do we build these zero knowledge proofs? In the paper, we describe a three-step pipeline, and in my talk, I really won't have time to go into it in too much detail. But this three-step pipeline, the first step is basically a zero knowledge, like a circuit that can decrypt the TLS 1.3 records in zero knowledge. And then in the paper, we describe how these circuits can be composed with other circuits that are kind of responsible for checking policy. And by composing these circuits, you can kind of do an end-to-end policy enforcement on encrypted traffic. So I won't talk about that, the latter steps of this pipeline, but I will talk about this zero knowledge circuit for decrypting TLS connections. So the question is, how do we decrypt TLS 1.3 records in a zero-knowledge proof? The most obvious way to tackle this is to just rerun the record layer decryption in the zero-knowledge proof. So basically express record layer decryption as a circuit and just decrypt the encrypted traffic in the circuit. So the problem with doing this is that TLS 1.3 records are not binding commitments to the underlying plain text because TLS 1.3 really only supports either GCM or Cha-Cha-20 Poly 1305. And both of these AEDs have the property that you can craft a single ciphertext that has multiple possible decryptions. So this means that a malicious client could lie about what it's putting in the proof, basically craft a ciphertext that has multiple decryptions, and then issue a zero-knowledge proof about one of these decryptions, but actually send a different one to the server. So this problem of kind of lying in the proof about the key that is used is one we need to tackle. So to fix this, in the paper we observed that you can use the handshake information to act as a kind of consistency check with the key that the client gives as input to the zero-knowledge decryption. So in the circuit, in addition to doing record layer decryption, the circuit also checks that the key that is given is consistent with the handshake information that was sent on the wire. So the question really boils down to how do we build an efficient zero-knowledge key consistency check for TLS 1.3? And so because TLS 1.3's key schedule and the handshake are quite complicated, I could get into the fine details here, and I'm sure everybody here would understand them, but it would take a lot of time that I really don't have. So I'll just skip most of the details here, but I first would like to thank the Dowling et al. TLS 1.3 analysis paper of like cryptographic analysis of the TLS 1.3 handshake for this incredible diagram of the TLS key schedule, which I think is like, this is like maybe the best diagram I've ever seen in a crypto paper. But anyway, so we don't really have time to get into the details here, but what I'll say is that the simple and efficient way to design this key consistency check is to just rerun most of the client's key derivation in the circuit. And so in the paper, what we observe is that the server finished value, basically the MAC that the server computes over the transcript, acts as a commitment to the intermediate steps of this key derivation process. And so by checking these in the circuit, we can shortcut most of the expensive operations of the client's key derivation and get like a key consistency check whose cost and the size of the circuit doesn't depend on the size of the TLS transcript. So I'll just talk very, very briefly about the results of our prototype implementation. We used the XJ-Snark development environment and the Groth 16 zero-knowledge proof system. And so the cost of this key consistency check, the proof generation, is about 15 seconds. And so in the paper, we explained that this key consistency check really only has to be done once per TLS session, which ameliorates the high cost of doing this somewhat, but it still is quite a high cost. This is pretty impractical at this point. However, once you do this key consistency check, actually doing like like for the DOT filtering use case I described before, the per packet cost of this is only about 3 seconds per DNS query. If you want to prove that your DNS query is not for a domain not on a block list. And finally, the proof verification cost here is the best of the three. We inherit the fast proof verification of Groth 16, so proof verification for the middle box only takes about 5 milliseconds. So the TLDR here is that these techniques are not practical yet, but they're really, really close. And there are a lot of interesting optimizations that are possible here. So like, for example, in ongoing work, we're using a different zero-knowledge proof system that reduces the client cost here by about 70x. But there are some caveats here, which I can get into if people are curious. And I encourage you, if you're interested in more of these numbers and more context, to see the paper online. So finally, I'll just conclude with some general thoughts about zero-knowledge proofs and TLS. So whatever people think of this particular research that my co-authors and I have done, I hope you'll agree that zero-knowledge proofs are a really, really interesting tool for lots of practical network security and privacy problems. So zero-knowledge proofs are in a really, really interesting place right now as a technology. They're really on the cusp of becoming practical enough to use in real applications. So one other interesting application specifically to TLS could be in other network security settings, it's important to see SNI values in plain text. So one possible application could be doing like zero-knowledge proofs about the contents of an encrypted client hello in a TLS handshake. And there are lots of other problems here, which for time reasons, I won't go over them, but there are a lot of other parts of TLS that we didn't really approach in this work on zero-knowledge proofs. So figuring out how to do things like client authentication in a zero-knowledge proof would be pretty interesting. And another very outlandish suggestion, which I'll just suggest, and I expect people to push back on this, but it would be interesting to me to imagine zero knowledge friendliness as a design consideration for future versions of TLS and indeed for other future secure channel protocols. So with that, I'll just conclude and take some questions. So thanks, everybody.
Hi, Ben Schwartz. So you mentioned the
Sorry.
idea of
Yeah. Sorry, to see the screen, I have to like end the presentation here. So.
oh well, that's fine.
Okay.
So you mentioned zero knowledge proof friendly version of TLS. Can you imagine a ZKP hostile version of TLS? What would that look like?
Well, the glib answer to your question is that TLS 1.3 is already the ZKP hostile version of TLS. And that sounds like a criticism, and honestly, it's not a criticism. TLS 1.3 is extremely well designed for the use cases that the designers envisioned. But some of the reasons why TLS 1.3, excuse me, is well designed are also reasons why it's quite hostile to zero knowledge proof. So for example, the kind of extreme precision and detail of the key schedule is something that makes it quite hard to do efficient zero knowledge proofs about, because in the key schedule, not only do you need to do a lot of kind of HKDF operations, you're using HKDF on a primitive like HMAC SHA-256, which is like not zero knowledge friendly. So SHA-256 is extremely expensive to evaluate in a zero knowledge proof. So the key schedule having this, there are lots of context hashes and like label inputs and everything, and there's lots of there's a kind of a hierarchy of keys. This is quite hard to do efficiently in a zero knowledge proof. Yeah. Yeah, I guess another thing. Well, yeah.
Okay, thank you.
But I'd be willing to. Off the top of my head, I can't.
Quick question is, how lengthy is the zero knowledge proof that you need to send to the middle box?
Yeah, great question. So this depends a lot on the specific zero knowledge proof backend that you use. So for our system, the proofs are quite short. So GRAS16, which is the proof system that we use, is really designed to produce extremely succinct small proofs. So the proofs are only going to be about 128 bytes in our prototype. And so the trade-off here is that GRAS16, the work of proof generation is relatively high. That this is kind of a trade-off in all existing zero knowledge proof systems, is that there's a kind of trade-off between the succinctness of the proof and the work that the prover has to do to produce it. So we're exploring like kind of different trade-offs here. Like maybe if you were able to accept like a 1 kilobyte proof, you could get a much faster prover. But currently our prototype is 128 bytes per proof.
Just as a comment, I think the proposition that visibility is a reasonable thing to want for TLS is contested. I wouldn't accept it at all myself. And I would encourage you to maybe do more research on trying to make this harder rather than easier, and slower rather than faster. In other words, it would be good research to try and figure out how to improve TLS to make these methods work less well, in my opinion. And it seems like as good a research goal, perhaps not as popular with certain people. So
it's probably hard to publish a paper like that.
Right, but sometimes protecting the security of the internet is more.
No, I understand. Sorry. Yeah.
But my question is, so you said that you have like a 15-second overhead and maybe a 70x speed up. How realistic is the 70x speed up in what time frame? Can you kind of give a feel for that?
So the 70x speed up relies on a different set of trade-offs for the zero knowledge proof system. So it's you, but in terms of time frame, do you mean like when could this be deployable, or
Yeah,
I guess I don't.
yeah. When might it get feasible to be 70 times quicker than 15 seconds overhead per TLS session?
Well, the backend, the zero knowledge backend that we're using, I mean, exists today. I mean, we're using code that was written by actually like a researcher at Northwestern, Xiao Wang. So the 70x speed up is the caveat here is that there are other trade-offs. So the middle box's verification cost is also quite a bit higher in this in the 70x speed up. So you think that you can imagine that like both the client and the middle box in this proof system would need to pay about like 200 milliseconds overhead of proof generation and also verification. So 200 milliseconds is quite a bit faster than 15 seconds, of course, but to be doing this on every packet, on every network packet is probably still impractical. So there are there's a lot of research ongoing in like these zero knowledge proof systems, and I think like in the next 5 years, I expect that people will develop techniques that kind of achieve the best of both worlds, where you have kind of more succinct proofs, but that are also faster to generate.
Okay, thanks. So my takeaway is that if the TLS working group is looking at trying to make these techniques less effective, then we have a couple of years to do it.
Right.
And we'd welcome your help, of course.
Well, thank you. I appreciate that. Although I would, if I can, I would just kind of like to push back a little bit on the first thing you said about visibility. I think it's very, very natural to oppose like efforts towards like kind of network visibility, but I think it's important to remember that the starting point, if you are taking a very pro-privacy standpoint, I think it's important to remember that the starting point here is not TLS 1.3 security guarantees. The starting point here is really networks where TLS is not used at all because it conflicts with these visibility requirements. So to me, the reason why I think this is an interesting research question and a very challenging one, admittedly, is that by doing these kinds of these visibility, by doing this kind of visibility research, I think we can improve the privacy of a lot of networks and improve the privacy of end users who today don't get to encrypt their communications because the network operators can't have this visibility into the traffic.
Okay. Thank you, Paul Ecker. Since we're 1 minute over, is it quick?
Yes. Thank you, Paul. Interesting talk. I'm looking forward to waiting 15 seconds to download things. So can you just briefly say what would make TLS more friendly to this? Is it just having committing ciphers, or is it something more fancy?
Yeah, that's a good question. So having committing ciphers would help. However, committing ciphers, they actually aren't the best way to solve this problem. They are the way that kind of in the past people have approached this, and like the kind of received wisdom in the crypto community about doing verifiable decryption is that, as long as your encryption is committing, then you can just kind of verify the commitment and everything's fine. However, in this paper, one of the interesting things we found is that it's actually, if your sessions are long lived, it's actually much more efficient to do a one-time key consistency check, and then rather than having to kind of check the commitment in every ciphertext every time you do a proof. So one thing that TLS could do is send as part of the handshake a commitment to the session keys. Even just as an extension, like if you sent this and had both parties kind of check these commitments, then this whole key consistency check, this 15-second cost that I described, would go away pretty much immediately, because the handshake would actually, to have a correctly set up TLS connection, you would need to check a commitment to the session key. And if the middle box can extract this, then they can just check subsequent proofs against this commitment that is sent by the client. Does that make sense?
Enough for the purposes. Thank you.
Mm-hmm.
All right. So we're 3 minutes over. Thank you, Paul, for talking about this interesting a new take on TLS and privacy and security.
Sorry for going over time.
No, that's our fault as chairs for not managing the time better. As discussed in the chat, the paper was shared on the list, so if you're curious, please check it out. Be interesting to see how things can be improved or not, one way or the other. And unless anyone else has any burning questions, I think we can wrap up here. Okay.
Bye.
Thanks, folks. Thanks to our note taker.